Hi everyone, we're still in this chapter entitled Surface Area and Volume, and we want to finish and to show how to use the concepts of volume and surface areas that we explained before in previous sessions, how to use it and how to and benefit from it in problems in real life. Okay, real life problems. For example, we have first of all, we have in this exercise a sheet of cardboard with 1,200 millimeter, okay, as a length, and the breadth 1,000 millimeter. We mean 1 meter, okay, millimeter, because from millimeter we're converting from millimeter to meter. We divided by, or we multiply by 10 minus 3, or we divide by 1,000. Has a squares of side lengths, so 300 millimeter cut. So we have squares on each side. We have we take off on the cut off a square. Okay, square with the side length 300. So normally, if we cut it, we cut this one and this one with this one, all the square located on corners. Then the side are folded, so we fold this side and this one. We will obtain this shape, I think. Okay, and we fold it to obtain a box. We have right now an open rectangular box. So how calculate its internal surface area? So the surface internal area, it is equal when folding it. We have this one as like a wall. We have this one as a wall. So normally the internal surface equal to the surface of this rectangular shape. So normally it is equal to this one, and we know that this length equal to 1,200 minus 300 minus the 300. My 600, so it is equal to 600 at the length, and the width of this rectangular equal to 1,000 minus 300, the 300, so it's 400. So it is equal to 400 by 600, 240,000 millimeter squared. The volume of the box equal to the internal surface, the surface of the base by the height, which the height of the wall. The height of the wall equal to 300. Easily we can see that. So to obtain this volume, but please keep take care of the measurement, the unit of measurement that we should properly use here, because we have a volume. Moving on to a next exercise, a carport and workshop are covered by flat rectangular roof, 3.6 meter by 11.2 meter. So we have a rectangular roof. If we calculate the area of this rectangular shape, so normally it is meter in meter. So we can multiply easily these two numbers to obtain the area of the rectangular roof. All the rain that falls on the roof is collected in water tank. If 3 millimeter of rain falls on the roof, so 3 millimeter, what we mean by 3 millimeter of rain falls on the roof, we mean the thickness of of rain. So not normally it is the height. So normally it is the height, but we should keep in mind that we should use the same measurement. We have here millimeter and we have here meter. So we have different measurement units. So it is very, very faulty to use it directly without any conversion. So we should convert a 3 millimeter to meter, okay, and it is easily divided by 1,000 to obtain the volume, the correct volume in meter cube. So normally we have a volume in meter cube, and they ask us to compute the volume of the water collected in the tank, but in liter. So in liter, we should know that we have 1 meter cube for each 1,000 liter. It is equivalent to 1 meter cube. So we have a 0.meter cube. So it is easily to divide meter cube by meter cube and we multiply its equivalent in liter to obtain 121 liter. So please, can you use a little bit your imagination and practice your as a self-assessment these exercises. And if you have any question, you can contact me whenever you want. So normally, moving on to the diagram, show the design for a concrete driveway. We have a concrete driveway. Okay. They ask us to calculate its area. We have a composite function. We had a composite shape. So when we have a composite shape, so we need to cut it. We cut it to have two simpler shapes as a rectangular one. This rectangular one is with length equal to 12 because we have a 10. We have a 12 length and we have a 3 other width, so we can multiply it to obtain the area of the rectangular shape, and the semicircle pi r squared, we multiply it by a half, or we divide it by 2 to obtain the area of the shape is 75.3 meters squared, approximated to the 1 decimal place. A concrete contractor charges $70 by meter squared to supply and lay concrete. So normally, for each 1 meter squared, we should pay the contractor charges $70. So we should know, we should calculate the whole charge. The whole charge of this contractor is we divided the surface to find out how much it contains, how much meter square contains. So 75.3 meters squared we divided by 1 meter squared to multiply it finally by 70 to obtain $5,271. And what about if the concrete needs to be 100 millimeter and not meter? So please open your eyes and always be aware about the measurement unit that you are using. So we have a millimeter, the deep depth in millimeter. So we divide 100 by 1000 to obtain 0.1 at the height in meter, to multiply it by the surface area or the area of the base to obtain finally 7.5 meter cubed as volume. Okay, so easy also. And also it is very easy here to, for example, because we have all the details mentioned, it is very easy to find out what is happening here. We have a pool, swimming pool, and with the dimensions, only we have to identify the dimension correctly, and also to, for example, let our imagination create our way to the correct solution. For example, here in the bottom, we have a half. We have a half, cut it diagonally, half of a rectangular prism. So normally, if we calculate the volume of a whole rectangular prism and we divide the volume over 2, we'll obtain what we want. And you should know that I am doing the same here. Finally, in the exercise 10, we have a 50 centimeter cubed block of metal is made into wire of diameter 1 millimeter. So how long will the wire be? Normally 50 centimeter cube, so 50 centimeter cube and wire of diameter 1 millimeter. From this word diameter, so we know that we are talking about cylinder because we are talking about a volume and not surface area. So because we have a centimeter cube, so it is volume. So we are talking about a solid with the diameter. So it is a cylinder. Cylinder 1 millimeter. So we should know that 1 millimeter as a diameter, it is a 0.5 millimeter as a radius, 0.5 radius, and we want to calculate all this one in centimeter cube. So we should know that from millimeter to centimeter, we divide by 10, or we multiply by 10 minus 1. So the radius equal in centimeter is 0.5 by 10 minus 1. So pi r squared, okay, by the height, because we have a volume of cylinder equal to the volume 50 centimeter cubed. And we complete all this we have only one unknown. We have we want to calculate the height and to evaluate the height. Okay, the height equal to 50 divided by pi divided by, it is a number divided by 0.510 minus 1 all squared to obtain finally the height in centimeter. So this all the exercises what I want to solve, and you can have the remaining one as self-assessment. Thank you for listening. Bye bye.